In the asteroid belt is a huge dwarf planet. It's called Ceres. Does it have an ocean underneath its icy crust? Let's find out.
Hi, I'm Jim Green, Chief Scientist at NASA, and this is Gravity Assist. On this season of Gravity Assist, we're looking for life beyond Earth.
I'm here with Dr. Brittany Schmidt, who is an astrobiologist and an associate professor in the Earth and Atmospheric Sciences Department at Georgia Institute of Technology in Atlanta. Brittany, welcome to Gravity Assist.
Thanks very much. Excited to be here.
So where is Ceres in our solar system and how big is it?
So Ceres is in the main asteroid belt, just about smack dab in the middle of it. It is kind of halfway between the orbits of Mars and Jupiter. The kind of neat thing about it is actually how big it is. You know, when you think of asteroids, you might think of something small, maybe something the size of your house. But actually, Ceres is about the size of the state of Texas. So it's absolutely gigantic.
So what makes it so special?
It's one of the only planets that's really made of this kind of frozen ground on the outside. So I kind of like to call it a permafrost planet, if you will. So if you think about the Arctic on the Earth, where the ground is frozen year-round, it's the same thing on Ceres. So it's kind of this frozen mud up on top. So that's kind of special. And it's really a weird object in that way.
Well, you know, NASA's Dawn spacecraft, which first visited Vesta and then left Vesta and went out to Ceres, it spent more than 3 years orbiting that dwarf planet and took spectacular images and other measurements. Tell us a little bit about what we learned from Dawn.
Dawn was a fantastic mission. It's really a testament to doing as much as you can with any mission. So as you're zooming in on a planet, getting closer and closer, those first images where it becomes more than a point of light, it starts to become a real place. I remember those first images because we could start to see every rotation, this kind of brightness that would kind of show up. And then as we zoomed in and we got closer and closer, you could see that there was almost, it looked like a flashlight in some of the images coming from this crater. And as we got closer, we could see that what it was is that those Ceres is very, very dark. There's also these really bright deposits in this crater called Occitan crater. And those bright deposits were reflecting a huge amount of light back at us. And when we got up close, what we could see is that these are definitely salts. And so salts are created in the interaction between water and rock. It happens on the Earth, it happens in other planets. And so what we think is that that is briny material, material from deeper inside Ceres that has come up.
Well, as you say, liquid water, in fact, must have some aspect to do with these briny, salty deposits. So do we think that Ceres has an ocean inside it or liquid water at some layer?
It looks like there probably is. The gravity data is consistent with that. It's very, very round, which is really hard for solid materials to do that very well. So liquids, but ice is another good way to make something kind of round. It can relax over time. So there is some evidence to suggest that deep down there might be some liquid layers. There's certainly evidence to suggest there might be brine pockets or former brine pockets. So a little bit of heat from an impact or something could really warm those up. So it's one of those questions that we think there's really good evidence for it, but it's not clear whether that's constantly liquid now or was recently liquid in the past. Studying places like Ceres, even if they don't have bugs crawling around right now, means that it's a really neat opportunity to understand planets as they form or as they existed just before life took hold. And I think that's just as special.